Today we look into sigma and pi bond. Sigma and pi bonds are chemical covalent bonds. Sigma and pi bonds are formed by the overlap of atomic orbitals. Sigma bonds are formed by end to end overlapping, and pi bonds are when the lobe of one atomic orbital overlaps another. Both have got their names from the Greek letters. Now, before we understand sigma and pi bond, let us understand the shape of s orbital and p orbital. So, the shape of s orbitals are spherical, spherical, spherical in shape. Now if we draw it, it will have a shape like this. So it's completely spherical in shape. P orbitals, bitals, p orbitals are dumbbell, dumbell, dumbbell shaped. Dumbbell is when people exercise, they use weights which are known as dumbbell. So the p orbitals are dumbbell in shape. P orbitals are dumbbell shaped, we can say. So say px, let's draw that, and then we can go to py and pz. So first of all, px, you can make straight line, and now px, if we draw it, it is like this. Next is py. So let's draw the py, straight shape, straight line, and then we can make a line like this, and then a line like this. And then we could draw the double shape. Double shape is like this. And then we have the pz. Let's draw the line straight like that, and then one line like this, and then another line like this, and then we can draw the dumbbell shape like this. So p orbitals are dumbbell shape, and they look like this. Now when we talk about the sigma and the pi bond, first let's define what a sigma bond is, and then we can explain how they are formed also. So sigma bond, sigma, sigma bonds, and we can write like this, sigma. So sigma bond are the strongest, sigma bond are the strongest type of covalent bonds, covalent bond, and they are formed by head on, they are formed by head on overlapping, overlapping, overlapping of atomic orbitals. Orbitals. So if you, let's underline it with a red color. Yeah. So sigma bonds are the strongest type of covalent bond formed by the head-on overlapping of atomic orbitals. So if we look at how they combine together, let's understand that. So they can bond together, says, by head-on overlapping of atomic orbitals. So suppose we have one like this and another like this, and we can draw this. So this is 1s and this is 1s. Now when they combine together, they combine in this way. Just as we talk about covalent bonds, they combine in this way, and this is how they formed sigma bond. So what we notice is the electron density, density, density is concentrated, CONCE, yeah, CONCENTRATED, concentrated between the nuclei of the bonding atoms. So it says that the electron density is concentrated between the nuclei of the bonded atom. So usually it is in between here, between the nuclei of the bonded atom. So that's where the electron density is concentrated when 2s combine. And how do they combine? They combine by head-on overlapping of atomic orbitals, and the electron density is concentrated between the nuclei of the bonding atoms. Now the two s orbitals, they can overlap. Just now we saw how they can overlap. They can overlap like this, head to head, or they can also overlap like s with a p orbital like this. Sorry, let's remove this. Yeah, with a p orbital like this. Yeah, and then it can also overlap in another way, that is, can make it like this and like this. So there are different ways they overlap head on. So we can say two s orbitals overlap head on. So that's the way how they can overlap SS or SP. So the real definition that when we talk about is sigma bond are the strongest type of covalent bond formed by head-on overlapping of atomic orbitals. So, and another very important thing, that electron density is concentrated between the nuclei of the bonding atoms. Now let's move on to pi bonds. Now if we define the pi bonds, what are pi bonds? So let's make it yeah. So pi bonds, p, we write it as pi, pi bonds, bonds, and we can give it a symbol as pi. So pi bonds are a type, type, a type of covalent bond formed, formed, formed by sideways or we can also say lateral, Lateral, lateral overlapping, Laoverlappingo, sideways overlapping of atomic orbitals. So let's underline that. Yeah. So pi bonds are a type of covalent bond formed by sideways. So they are formed by sideways or lateral overlapping of atomic orbitals. So if we draw the diagram, we can draw it like this. Let's draw it better. Yeah. So take it down like that, and then we can draw. This is one, plus we can use the other one. This is another one. So, and then we can draw another figure like that, and another one showing the sideways or lateral overlap, and this is how you can show the density of electron. So a pi bond is formed by, it's a type of covalent bond formed by sideways or lateral overlapping of atomic orbitals, and as a result the density of the electron density we can write down. What does this lead to? This leads to the electron, electron density, density. If you see in the figure over here, the density over here, so the electron density is above and below, below the plane of the nuclei, nuclei of the bonding atoms, atoms. So here we can see very clearly that the electron density is above, this side above and below the plane of the nuclei of the bonding atoms. So I hope this is clear to you. And we can also say that the density is above and below the plane of the nuclei of the bonding atoms. And we can also show another type of diagram. If it's there, we can also draw this type of diagram. We just make over here, this is the pi bond actually, BOND, and we can again show another, that is electron density at the top and bottom, and then we can show the nuclei of the bonding atoms. So this is the pi bonds and then the sigma bond. So the type of overlap that we have, we can talk about it also. So we can say type of overlap, OVRLAP, and then we can make a line like this, and then we can say type of bond, that is type of bond formed. So let's go into it, let's talk about it. So the first type, sigma, what we see is there is a S head on. So that's a sigma one. Type of bond will be sigma, so we can give the sign like that. Then we have another one like S and P head on. This is again sigma, SIGMA, sigma bond. And then we talk about the pi bond, PP head on. HEAD, head on. Remember, it's sideways. So this is no, this is PP still. When we talk about this is PP, head on. This again sigma. Remember this, not sideways, it's a head on. So it's sigma bond. So if you look at the diagram, you'll see it's head on over here. This we're talking about this one over here. So that's PP head on. We can say PP head on. And then we have, finally we talk about the P, sorry, let's change the color. Yeah, finally we talk about the P sideways, that is lateral. When we talk about sideways, that is lateral, sideways, and we can say lateral. We can also call it as lateral, and this will be pi bond. Let's not write pi bond, just rub that, and we can just put the sign over there. So SS head on is sigma, S and P head on is sigma again, and PP is head on is again sigma. So PP, when it is sideways, then it is lateral. That means in case of when we talk about sigma, it is we just let's do that. Yeah, when we talk about that, it could be like this, that is sigma. But here it is sideways will be, we just talked about it, sideways will be like this. So like that. So remember this. So this will be pi, and here it will be sigma. So remember that. So let's move on. Now let's again talk about the bond. So type of bond, and then we can say sigma. Let's write down that more clearly, otherwise, yeah. So sigma, SIGMA, put a sign over there, and then we have so let's this, yeah, and then we have pi. We can write that down, yeah. So we have, this is the type of bond. Then we talk about we talk about type of bond, then sigma and pi. So let's go into that. So when we let's take out this, yeah, when we talk about the sigma single covalent bond, when we talk about the single covalent bond, so we can say single, SINGLE, single covalent. I don't know why this, yeah, let's rub this, yeah. When we talk about single covalent, yeah, COVALENT, single covalent. So in single covalent there will be one sigma, and there won't be any pi, so we can write down 0. Then we come to double covalent, DOUBLE, double covalent bond, COVALENT, double covalent bond. In double covalent bond, one will be there will be one sigma, and there will be also one pi. And then we have triple covalent bond, TRIPLE, triple covalent, VALENT. Triple covalent will have one sigma and will have 2 pi. So this is how we talk about the bond and how many single and how many double it has. So when we talk about single bond, that is alkene, we will have only one sigma. When we talk about double covalent, that can be alkene. That first one was alkane, sorry, single bond. Second is alkene, one single and one pi. And alkyne, that is triple bond, will have one sigma and two we can say pi. So when we talk about single, let's talk about single. So let's talk about C2H, that is 6, yeah, that is alkane. So if you look at alkane, we put 2 carbon over there and hydrogen hydrogen, hydrogen, yeah. So here we talk about single covalent bond. All are sigma and there is sigma only, sigma bond over it. But when we talk about this, can be single bond, single bond or single covalent bond. The second one we can talk about C2H4. Now this is double covalent bond, so we, this is like this, yeah. And then here we can see the first one will be sigma and the second one is pi. And when you look at the triple bond, that is C2H2, so if you draw the structure, C and a triple bond there and a C and single bond H over there and a single bond H over there. Now in this structure, that is in triple bond, we can call this as ethyne because it's a triple bond. What we observe is there is one sigma bond. This one, if I mark it with red, this one is we can say a sigma bond, and then the other two, if you look at it, is pi bond and pi bond. So we can say triple covalent bond has one sigma bond and two pi bond. So this is finally the sigma and 2 pi bond in the triple bond. So I hope you have understood the type of bond of sigma and pi bond and overall the structure of the bond formation of sigma and pi bond. Students, if you like my videos, you understand my video lessons, please subscribe and also share with your friends. Thank you.